V41 begins on slide 21 and covers rates, unit rates, and population density. Slide 22 defines what rates are. A rate is a ratio of two quantities that are measured in different units. So here are some examples of rates. You have 4 participants per 2 teams. Participants are not the same unit as teams. 5 gallons per 3 rooms. Gallons are different from rooms. And 8 burgers per 2 tomatoes. Burgers and tomatoes are 2 different units. Slide 23 defines unit rate. A unit rate is a hot topic we've had before, but it's defined as a rate with a denominator of 1, and it's often expressed with the word per. So as you can see, per, the symbol for that is a backslash. So 34 miles per gallon, 2 cookies per person, 62 words per minute. Again, notice that a rate has 2 different labels. Miles are different from gallons, cookies different from people, words different from minute. So this is a review of how to find a unit rate. Slide 24 models 6 friends have pizza together. The bill is $63. What is the cost per person? So since we're trying to determine the rate of one person, you have the cost over people. So the problem begins with $63 as the cost, and people are 6. So $63 for 6 people. We want to find out how much it is for one person. So if you do 63 divided by 6, you'll find the unit rate of $10.50 per person. Again, that was $63 divided by 6 to get $10.50, but because it's a unit rate, you must label per person. So $10.50 per person is the unit rate in this problem. Please write skip on the next slide, and we are going to do the next problem on slide 26. 60 cupcakes are at a party for 20 children. The question asks how many cupcakes per person. So we're trying to find a unit rate. It's C for cupcakes over P for people. So there are 60 cupcakes and 20 people. 60 divided by 20 is 3. So my final answer is not 3 cupcakes, but rather 3 cupcakes per person. That is the entire answer, and you must have cupcakes per person. Please pause and solve number 27 when you are finished. Skip to slide 32, and please make sure that you show all of your work. You may use your calculator to solve for the unit rate, but please set it up on this slide first. As you have seen in the past, unit rates are helpful in determining which is the best buy, or in this case, who is better off. So we're comparing 2 different rates, one from Sebastian and the other Alexandra. Sebastian and Alexandra both work during the summer. Sebastian worked 26 hours one week and earned $188.50 before taxes, whereas Alexandra worked 19 hours and earned $128.25 before taxes. Who earns more per hour at their job? So this is not done for you. You must write this on your slide. First, we're going to look at Sebastian. Sebastian worked, it's money per hour. So money on top, $188.50 over 26 hours. Again, that's Sebastian who worked 26 hours at $188.50 total. So his unit rate is $188.50 divided by 26. Sebastian is $7.25 per 1 hour. On the other hand, Alexandra has money per hour, $128.25 per 19 hours. divide numerator by the denominator, and you get 675 per hour. So if we compare, 725 is more money in 1 hour than Alexandra, who has 675 in 1 hour. Therefore, the correct answer is that Sebastian earned more per hour. And Sebastian, if you want to make it a better, stronger response, you could say Sebastian earned 50 cents more per hour. Slide 33 models another comparison of Jim and Tara, where both of them are traveling in their cars, and we want to find out which person's car gets better gas mileage. Well, gas mileage is determined as miles per gallon. So miles over gallons. For Jim, again, this is not on your slide. So first we're going to do Jim. Jim traveled 480 miles and his tank is 15 gallons. So 480 divided by 15 leaves Jim with 32 miles per 1 gallon. Then we need to figure out Tara. So Tara traveled 540 miles on a tank with 18 gallons. So 540 over 18 for Tara. And again, you want to keep the miles on the top, gallons on the bottom, because we're doing miles per gallon as our unit rate. 540 miles for 18 gallons leaves Tara with 30 miles per gallon. In this case, gas mileage means you want to go farther per 1 gallon, because then you spend less money. So Jim can travel a longer distance in 1 gallon than Tara can. And so Jim has the better unit rate. So Jim can travel 2 miles more per gallon than Tara. Please write turn on this slide and flip the page to slide 34. 34 is your turn, where you are going to model out and solve the unit rate for Tahira and Brandon. Once you have your final answer, skip to slide 39, but before you do so, please write Juno at the bottom of slide 34. Slide 39 defines population density. Population density is still under the same topic of unit rate, but it's actually a unit rate of people per square mile. So for population density, it helps determine how crowded or spread out areas are. So for example, New York City probably has a much greater population density than Clark, New Jersey. There are more people living per square mile in New York City than in Clark, New Jersey. The formula for population density is no different than finding a unit rate, where we're comparing two different units. Population is the number of people over area, which is in this case a square mile. Slide 42 models population density in New Jersey. So first we have to find the population of our state, which this slide says 8,791,894 people. And then the area of New Jersey is 7,790 square miles. That means if you have 1 mile to the east and west and 1 mile north and south, in the end, New Jersey is made up of almost 8,000 square miles. So again, population density is the population over the area. So the population divided by the area shows that New Jersey has a population density of 1,129 people per square mile. So that means in 1 square mile, on average, there's just over 1,000 people living in that area. Slide 44 is showing the population of Newark, and it's asking for its population density. So at the bottom, I started this problem for you. Population density is a unit rate where it compares population to area. So population divided by area. So we have to look for the population in Newark, which is 278,980 people, divided by the area, which is 24 and 1400 square miles. So please pause the video, finish this problem and the next one on 45. Once you are finished with 45, please write the end at the bottom of this slide. We will go over these problems and more in class.